Hello guys, welcome to the new video again. So in this video we are going to in previous lectures we covered divide and conquer techniques, design techniques, all that. This is design techniques. Now we will introduce YouTube for greedy method, control abstraction and abstract problem. So how we will do that? So what is greedy method is used for solving problems whose solutions are viewed as a result of making a set or sequence of decisions. All right. So right. So used for solving problems whose solutions are viewed as, we can say, making a set of sequence or of decisions. All right. So these decisions are made in a stepwise manner. All right. So decisions are made in stepwise, first decision, second, then third. Right. Then we come to the conclusion and for the answer also. Right. So at each step out of all options, greedily select that option which satisfies the given criteria of the problem also. So if we want to maximize the output or minimize the output, according to that, we will select greedily, all right, at each step. The terminology for greedy algorithm technique would be problem definition and constraints. So definition of problem, we also that constraints would be conditions or requirements. All right, we are some constraints means rules to be followed in the solution. Right. So conditions or requirements would be my what we I will consider that implicit or explicit. There are two types of conditions requirements from the solution. That implicit conditions would be local conditions, row, column, diagram. You can say explicit, that means boundary conditions. You can say the explicit is has more meanings also. So we will see, all right, after. So what is solution space is all possible ways of organizing inputs, satisfying only explicit constraints. What are we saying that in greedy method, all possible ways of organizing inputs, right? So satisfying only explicit constraints. So for example, let's say this is an equine problem, all right? So in an equine problem, Q where n queries and n is equal to 4, then Q1 to Q4 there are 4 queries and there is a matrix for 4 by 4, all right, matrix. So int 1 dot n. So here this is a column in which q I is placed. S1 to n 2 1 4 in which column q I is placed. So n is equal to 4. Let's say each problem will have its solution space as a function of input side. What is he saying that each problem will have its solution space, alright? It's a function of input size Or now for n quiz problem, it is n factorial. Alright, there are n factorial. Alright, so we will go to solve this that right. So here what we will do is let's say that each problem will have its solution space. Well, yeah, is all so n factorial. How n factorial possible that n cubed problem? It is n factorial. 2 to the power n square of infinity. It is n factorial. It is how is it n factorial? That if it is 3, then 3 factorial it would be 3 into 2. It is equal to 6. All right. So it is 1, 2, 3, 1, 3, 2, 3, 2, 1, 3, this, 3, this. Three possible ways, alright, of solutions of input sequences, alright. But in which sequence we will place these. So input space is only explicit constraints, input satisfying, organizing inputs only, alright. So feasible solution is are those solutions in solution space that satisfy implicit. What are feasible solutions? So feasible solutions are the solution in the solution space that satisfies implicit constraints of the problem. Problem may have multiple feasible solutions. Alright. So feasible solution would be that the implicit constraints, which means that the local constraints to the problem, local to problem, right? There would be implicit constraints. So objective function, few problems may have objective function which tries to minimize or maximize a given criteria. So objective function, very few problems may have objective function which tries to minimize or maximize a given criteria of a problem. Right? Optimal solution would be is that feasible solution which solutions by the objective. Uh, okay. Feasible solution which is satisfy this. All right. So problem may have multiple feasible solutions also. Shortest path from for a graph is a what we say objective function would be minimum the cost of path, and yeah, this is the past problem with the optimal solution always refers to the value and has. So what we are saying that optimal solution always refers to the value and hence it is always unique. Alright, it will be always unique and it's the solution optimal solution always refers to the value. Alright, hence it is always unique. So what is objective function of NQ problem? Objective function, right? No objective function. Just need to we need to satisfy or find a feasible function only. So what we are going to do here is searching and quiz sorted. let's say there is a problem P, alright. So its result is always either yes or no, right? Decision and we searching and quiz sorting. These are some greedy approach problems. So optimizer requires to determine the max or minimum value of a given criteria. This is optimization. This is a true false 0 1 feasible solution. So what we are saying that its result is always either yes or no. Alright? True, false or 0 1. So the decision problems. Alright? Problems are two types: optimization problem and decision problem. Right? So what we are saying that in the decision problem, the feasible solutions are required and will be either yes or no. Right? And optimization requires to determine the maximum minimum value of a given criteria. Right? Optimal solutions or objective function. It has right? Programs if we divide two types. CPU solution optimization problem. This is optimization. Then conceptual algorithm is decision problem. Congestion control optimization. So gateway for what is this? So control abstraction of general method, we can say that algorithm greedy is A of n, right? Principle of local optimality, right? Optimal 1, optimal 2, optimal 3, optimal 4. Time complexity of at least order of n, right? So algorithm greedy of A of n constrains the n inputs, right? Solution is equal to initialize the solution. If I is equal to 1 to n, do X select A, right? If feasible solution, comma X solution equal to union. If feasible solution, comma X, the solution is equal to union solution, comma X, right? So yeah, the written solution all together. So that there is a problem knapsack problem, right? So how do we solve these knapsack problems? That the given a knapsack of capacity n bag. This knapsack means bag, right? So given n objects O1, O2, ON, right? So given n objects that O1, O2, ON, these are some objects which has weights WY, profit along with its PI. Decision we would take is Excel. Maximized objective would be maximize the profit. And all right. If object of weight WY is put into the knapsack, then knapsack gets filled up by weight and we get profit of PI. All right. And maximize the profit subject to the what condition that the total weight being put into the knapsack does not exceed its capacity. So the total weight should not exceed the capacity of the knapsack. So let's see how do we are going to deal with that knapsack problem. So there is a two type of knapsack. Is a fractional knapsack and binary knapsack, alright? So fractional knapsack would be that what? Just a 4 year. Fractional real consumer, that means it it can be divided, alright? The value of this infinite times. But binary knapsack is 0 or 1. That means either included totally or excluded. Only, right? Fractional real customers, consumers, right? So I is equal to n, right? W of I is less than equal to n. Total weight, total profit would be about I to 1 pi, right? Xi is equal to 1 here. no decisions. For solving the problem, then where y is greater than m explicit constraint, right? A trivial solution. I don't. Right. Right. So it's more outfield outfield than it's we have a polygon. So if outfield is called cloud. Right. So decision xi on pi. Decision on object y xi wy xi profit I xi. All right. There are two decisions. Max the pi xi. All right. Object of function subject to what? It's an implicit constraint. All right. Y xi less is equal to a always. Well, is explicit constraint. Yeah, what is explicit constraint here? Here. Yes. About is comments in about. So x1 to xn here and solution space fractional 0 next sec what dynamic program the greedy method, right? So xi 0 1 left sec to power solution space here. So let's say n is equal to 3. There are 3 objects, right? Image capacity is this, and these are the weights of them. The profit fractional left side is there. So if greedy about profit, all right, x1 1 30 and what 5 and 1 by 15 of 15 of what? This is 20 here, right? So this is pi xi 25 2 by 5 25 8 plus 0 28.3. It is a profit. So the greedy weight 1, greedy about weight 2 by 3. Minimum weight would be what? Greedy is this? 3 is 1, then 2 is 23, 50, 20 weight, 31. So, weight of profit or of weight I, right? Profit should be per weight, alright? So, we will see it in the next one. So, stay tuned. Thank you so much.